Hello everyone, this is Anna Ravana. Today I'll show you a short pipeline that ZBrush uses to create a basic model and model with the correct topology. I'll show you how to use these tools. This will be a very short overview but useful for those new to ZBrush. And then we will create a basic dinosaur model with these tools. If you already know how to work with ZBrush, just open the second part of the video. So this is how our workspace looks like. It will look different for you because I have a customized interface. Create a document by going to the Document, New Document tab. Now we can start sculpting because we have a 2D brush mode enabled. We need to select the base shape for sculpting. Go to the Lightbox panel and select Sphere 128. The number in this case is the density of the mesh, but we'll continue to make various modifications with it, so it's not important for us now. You can see how new buttons just appeared on the side panels. I'll show you how to put them on your panel and tell you their functionality. The program is most often used to create the digital sculptures. The ball we just created is an imitation of real plasticine or clay. We don't really need topology in the early stages of sculpting, so let's not think about it now and concentrate on the shape of the object. Now I'll tell you how to use the pipeline using the DynaMesh, ZRemesher and project tools using a starfish model as an example. Let's deal with navigation first. To rotate the camera around the model, we just hold down the right mouse button and move. You can use the left mouse button on a free space or a similar button on a pen from a graphic tablet. By the way, there is such a function so that the model rotates relative to the area on which we are working now. You need to press the local button. You see it's now activated. If we disable it, the camera will always rotate about the center of the model. There are several modes of working with the model. Here we see draw, move, scale, rotate. The functions are similar to those in other 3D packages. However, all functions are already in one pivot. There is, even by choosing the move function, we can move, compress, scale and rotate. So I'll squeeze it a little now so that we don't get lost in the projection. There is such an echo-share icon here, which shows in which projection we are now. Here we are looking at the sculpt from the right side, now from behind, from below. If you just rotate the camera around the model with the left mouse button, then it's very difficult to get exactly into the projection. For this we need to use the Shift key. We rotate the camera as before, then hold down Shift and the camera is magnetized to the nearest projection location. These tools have hotkeys, accordingly QWER on the keyboard. We will stay in draw mode. Here we can see a button that turns on the display of topology and polygroups. The shortcut key is Shift F. Like I said before, I have a customized interface. Let's customize the interface for you. To do this, just click on the Preferences tab, enable Customize, and as you can see, the appearance of the interface has changed. Now we have areas to which the program offers us to transfer some tools and brushes. I've added functions like DynaMesh, Divide, and ZRemesher here, although they also have hotkeys. Let's find where they are originally. In the Geometry tab, we see a large Divide button. Hold down Ctrl-Alt plus left mouse button and move it wherever you want. I already have this button on the panel, so I'll just release it. Further, the DynaMesh button is located here in the DynaMesh tab and a little below the ZRemesher button in this tab. All three of these functions are found in the Geometry tab. If the tab is collapsed, click Geometry and here we see all these buttons. I also have other buttons here. Let's add a project. We have it, wait a little, I forgot because I don't use it from this panel. And yes, here in the Subtool, Project tab, here it is. We also bring it out to the side panel. Later I will explain why we need all of this. For now, I think it's enough. But we add a few more brushes to the bottom panel. I recommend using these brushes as basic ones. You can add others as you like, but there is a second way to quickly call the brushes. If we press the B key, then we can see a lot of brushes. But if you want to see all of the brushes that exist in the program, then we need to go to the Lightbox panel, Brush, and now we see a lot of folders with laid out by category with brushes. There is the same brushes that we see when we press the B key, but here we can find all of the brushes that are in the program. For a start, I recommend working with this set of brushes and then experimenting with new ones. How to do it? Find the tab on the right side panel, scroll down and find the brush window. Let's select the brush, let it be Deco. We see its small icon and now we can bring it to the free panel with the Ctrl-Alt keys held down. But as I said earlier, there is a second way to quickly call brushes. To do this, you have to remember the keyboard shortcuts, as if you were casting a spell in some game. Press the B key and then we look with our eyes for the brush we need. For example, Morph. We press the M key and see all the brushes that starts at M. Then you just need to remember the next letter, for example O, E, T, V, U, D. So if you want to call the Magnify brush, for example, then you can generally press BMA alternately while looking at the screen and the brush has already been selected. The logic of the third letter is also from the name of the brush, but it's already individual for each. You don't even need to bring the brushes to the bottom panel if you remember the letter combinations you need and can quickly type them. You will have your favorite brushes and not use all of them. So, we have customized interface. By the way, if you don't like the basic orange color, then you can also change it. We can make it here in Preferences, Eye Colors. We have windows with a palette on the side here. We'll not touch on the topic of texturing here for now, but we can choose some color for the interface, for example, purple. And then we see a lot of intimidating multicolored buttons here. Click on one of the colored buttons and now we can see how all the sliders have changed their colors to purple. Now I don't like the combination of colors. I have to return it as it was. Select blue and click on... hey, that's it, it worked. And also on top are these two windows. In general, you can only replace the orange icons. So, okay, we don't have much time. We have finished with the color settings. You can still study this tab yourself. Next, we deselect the Enable Customize tab and click Store Config. And then we have a window that says that all settings will be saved the next time you start the program. In this way, you can remember which commands and brushes you use most often and bring them to the front panel as you like. So let's go back to gray. We can already start sculpting something, for example with the clay build up brush, but we want to make a symmetrical model. To activate symmetry, we need to press the X key here. Now brush strokes mirrored. And with this symmetry we can already draw something that looks like a starfish. Take for example the move brush and draw out rays from the disc. We have already got something that looks like a star, but what if we want all the rays to be the same and these parts have the same length and shape? For this we have a radial symmetry. We won't need it to the dinosaur, but I'll show you anyway. The symmetry settings are in the Transform tab, right here. We activate the R button, which means radial symmetry. The slider next to it allows you to edit the number of duplicated points, in this case the number of rays of the star that we need. Here we can also select the axis of symmetry, X, Y, Z. Look, now I'm building symmetry along the Z axis. We can deactivate symmetry. We can turn on the Y axis. As you can see now the points appear in other places. Accordingly, this is how symmetry will look like along the X-axis. But for this you need to deactivate the Y key. Or you can turn on symmetry along all axes at once. And back to the symmetry along the Z-axis, which we need. And the R button must be active. And here there is also one active button with the letter M. It's responsible for the mirroring of the symmetry. Let me demonstrate to you. Just turn off radial symmetry first. Here's how mirror symmetry works, and here's what happens if you turn it off. The symmetry is still there, but the geometry will repeat the movement of the brush from either side without mirroring the geometry. Let's go back to the starfish. Turn on radial symmetry again. As you can see, it works, but now we have it on a different axis. We select the Z axis and attention. This is magic. In general, the shape already resembles a starfish. If this is your first model, it's enough to be proud that your first model is not ginger root, because the first model of everyone who works in ZBrush is ginger root. Even if you try to draw a plant or an animal, or I don't know, character, if you are very confident. My first ZBrush sculpt was a marten, a squirrel-like animal who doesn't know. Guess what I finally made. Next, we can do something with brushes. Try different brushes. I'll take the clay build-up brush. We can resize it by pressing the S key. Then we can smooth out the brush strokes by holding down the Shift key. On the top panel, we can control the intensity of the brush. We'll not get too carried away with sculpting, since we need this model to demonstrate the pipeline. Next, I'll show you something. We pull the rays out of the disc and turn on the mesh display. I would even stretch out the rays even harder for clarity. We stretch, zoom in, and see that the polygons in these places are stretched like treats on the fabric. What's bad about it, you say? And I will show you. Let's take a brush and try to paint in this area. As you can see, strokes look broken, in contrast to the area with uniform polygons in the center. Of course, we can smooth this area, but if we need details here, then they will not be visible, or with such kinks. You can compare how this brush behaves in different areas. We can fix this. Let's turn on the topology display again, and as we already know, we can activate the DynaMesh function. Let's open in the window where it's originally located and see what settings there are. We'll not study everything in this tutorial, we only need one setting to start with. This is resolution. The higher number on this panel, the smaller polygons will be. But the convenience on this function is that it allows you to recalculate the mesh in the model, like this. This is a mesh with a resolution of 72, so we can reduce it to 40 and see what happens. The mesh is not recalculated if no action has been taken, so we'll make a brush stroke, and now, as you can see, we can recalculate the mesh again. This feature is very convenient in the early stages because we can stretch the model as we like and then recalculate the mesh and make it uniform. Therefore, the basic model is best started with DynaMesh. To recalculate the mesh, we need to hold down the Ctrl key and drag the left mouse button, or the stylus to the side next to the model. Be sure to take some action between the recount. For example, you decide to increase the resolution, then first draw a brush stroke to recalculate. If after that we decided to lower the resolution again, then, as you can see, nothing happens until we again apply some action to the model. But we don't need such a dense mesh now, so we'll stay at this resolution. And now you can already see how the same brush that we used in the beginning behaves. No kinks in all areas of the model. Now I advise you not to go into detailing. Notice how the smoothing of some details behaves at the current mesh density. Everything smooth well, transitions are smooth, but if we increase the resolution to add finer details, then after smoothing the brush stroke will have sharper edges. This is good in one case and bad in another, so there is a way in which we can edit the model at different levels of detail. And also this method will help you if you have already drawn the details but want to change the topology and keep detail at the same level. Let's draw some details as an example, something like it swarms of starfish. By the way, here's a good example of where the topology should be recalculated. Let's say there is some detail here, and we want to start working on smaller elements, but at the same time interact with a larger mesh. The sequence of actions just needs to be remembered. First, duplicate the model by clicking Duplicate and the subtool column. Now I have two identical subtools. For now, turn off the display of the bottom one by clicking on the eye icon next to the subtool. Next, we need a function called ZRemesher. We move it to the bottom panel, but let's see its settings. There is a resolution parameter here, just like DynaMesh, only it's called target polygon count. What is the difference between DynaMesh and ZRemesher? Pay attention to the topology structure. Here we see both triangles and squares, which are chaotically adjusting to the geometry. They look like stitched pieces of fabric. We cannot trace the movement of individual edges, there are no loops. If you already met with the topology for animation, you know what I'm talking about. ZRemesher makes automatic retopology, rebuilds the mesh relative to the shape. You can compare this process to tiling a sculpture with ceramic tiles. I'll show you this process by hand using a dinosaur later. Now let's see how automatic retopology works in ZBrush. Oh, this is what happens if you forgot to turn off the symmetry. Disable it on X and try again. Here, as you can see, ZRemesher tries to build a mesh according to the geometry, using ringing edges, loops. Look, nodes have been created at the intersection of the rays of the star. Well, almost one node of the surf turned out. If there was the same here, it would be good. And these details could be made better too, but for now this is enough. Turn on the topology display and see that the model looks angular. We could increase the resolution with automatic retopology, but this wouldn't be the right decision. I'll show you better. Next, we press the Divide button. We brought it to the bottom panel, the hotkey is Ctrl-D. This function multiplies the density of the mesh by 2, but we can still go back to the first level. As you can see, the mesh has smoothed out, but let's see what the model looked like before retopology. The details are more readable here. Does this mean that the model smoothed the corners during the topology? Yes, but the good news is that we can restore it. This is why we duplicated the model. Let's turn on the display of both models and see where the differences are. Now let's remember the Project All button, which we brought to the sidebar, and take a look at its settings. This feature allows you to copy geometry and color from another model, but only if they already look similar. We don't need the color now. Press Project All, turn off the first model, and we see that the polygons are magnetized to the first model. Now we don't see any errors in geometry here. However, if the difference between the models were more pronounced, then artifacts could arise. I'll try to simulate such a problem for demonstration. I'll move the spot a bit, and here I stretch and click the project button again. Now we see that some of the geometry couldn't be magnetized. To reduce the chance of such a problem, we need to use this function by gradually increasing the divide level. First, we use the project on the largest polygons, then on smaller ones, and those increase to the highest divide level. As you can see, we can switch between levels. This function also has hotkeys. D increases the level of detail, Shift D decreases, but this only works on already created levels. We turn on the lowest divide level, both models are displayed. the edited model is at the top. Press the Project All button. We see the same problem that was earlier, but now we can smooth it in a way that cannot be done with a dense mesh. Now, when we increase the polygon, it will be easier for us to edit this problem. By the way, here we also edited the spikes and ZBrush did it, no problem arose. Then press D, see how the model has been smoothed here, and press Project All again. Check for artifacts, and then in the same way we rise to the highest divide level. And that's all. Now we can compare both stars and see that there are almost no differences. However, the difference is in technology and convenience to edit the model further. For game model, this topology is still not the most optimized, but if the number of polygons is not important for your purposes, then ZRemesher is a great way to quickly create a retopology. This function actually has a more advanced way to control the topology. For example, we can create new polygroups and give the ZRemesher task to build a mesh relative to these new polygroups. But this is a separate topic. The main thing now is to remember the beginning. Let's go over the stages of work. First, we create a primary model in DynaMesh. Do the most drastic stretchings of the model. Then we create a duplicate, apply the ZRemesher function to the new model, add divide levels, DynaMesh, ZRemesher, divide, and at the end we use the Project All function in stages. Instead of ZRemesher, we can use any other 3D package if we need to retopologize this model, and then apply this entire pipeline to the new model. As you already know, we can create a basic dinosaur shape using the DynaMesh tool. We can draw out the tail, limbs and everything else from the ball and then recalculate the mesh. We can, but I have one more tool for you, thanks to which you can create the carcass of any other complex model. It's called ZSphere. So this is what the workspace looks like when working with the sphere. You can find it here in Tools or open the lightbox and the sphere will be at the end. Here. I suggest turning off perspective here and symmetry on the X key. We will work using the same Draw, Move, Scale, Rotate tools. Let's try to create a second sphere. Turn on the Draw mode and drag the pen from the sphere to the side. Don't click. Let's switch to Move mode and try to move the sphere we created. Scale and rotate. Try it. Such a corrugation has formed between the spheres. It's here only for visualizing the frame, only spheres make a shape, but we can add a sphere in the middle of the corrugation. To do this, click on it in Draw mode, and now we see a new sphere, which can also be modified. And we can also delete it. Switch to Draw mode and hold down the Alt key and click exactly on the center of the sphere. Please note that the center should be highlighted in green, not a bone, but a circle in the center of the sphere. You can accidentally remove the corrugation, but this will not give you any effect. I'll show you later. Then there are several other features. For example, we want to create a sphere the same size as the previous one. To do this, we create a new sphere and then hold down the Shift key. And, as we can see, the child sphere has become the same size. Let's delete it. There is also a function that allows you to fix the size or the created sphere. In the same way, we start creating a sphere in Draw mode. Then hold down the Ctrl key and the sphere stops changing in size, but only changes its position. There is. We fix the size and move. The Ctrl key has two functions. You could accidentally get something different. Don't be confused, I'll show you now. We create a sphere, hold down Ctrl and then release a click again. Look, now we're kind of drawing with a pen, but it still is a sphere. Notice, here the sphere shrunk down when I was drawing because I decreased the pressure of the pen. This function is sensitive to pen pressure. It can be used to create some kind of ropes or horns or something like that. Let's try to create something using the tools we already know. For example, Martin. Oops, I did it again. Next, you need to remember one thing, it's about where the original sphere should be. In fact, it's that it has a slightly limited functionality, and if you place it, for example, in the middle of a spine, then you will be tortured later to change the shape of a spine, adjusting all spheres to the main one. Therefore, let's take it as a rule that the base sphere is stationary by default, although you can still move it. I'll show you, look here. For example, we are drawing the base of a four-legged animal. Here we have their head, ribs, pelvis, limbs, tail. I recommend placing the base sphere in the area of the pelvis bone. It's the same with the character. Here is his head, everything else. I will not draw the other hand. The main sphere will also be located in the pelvis region. If this is some kind of a plant, tree, then the sphere is at the roots. It just needs to be remembered. What's next? Let's imagine that we have created the carcass, we like it, we want to start sculpting, but first, check how the sculpted form will look like. To do this, find the Adaptive Skin tab and see the Preview button. Click on it. Hotkey A. Turn on the topology display and we see that each ray has its own color. This is called a polygroup, but we are now interested in topology. We can choose in what form the topology will be. This is now a DynaMesh view. There are two important parameters on the side. This is density. Let's move the slider and there is a DynaMesh resolution parameter. Reduce it to 0. Look, we have disabled that option and the topology of the model has changed. In fact, we can set the correct topology by moving the spheres and it will adjust. The choice of a method depends on the task. If you're planning significant changes in the form and you will be doing with topology in any case, then choose DynaMesh. If you need a simple model and the topology in this form suits you, leave it as it is and make small corrections. Try to switch these two parameters and see the result. Let's go back to the spheres view again by clicking on A and turn off the polygroups, Shift F. Next, we will analyze common mistakes when working with the ZSphere tool. The first mistake is when the spheres are too close to each other, or the sphere is inside another, or the intersection isn't correct, the corrugation becomes translucent. We will not see the error now, but try to pay attention to such errors. If this is a problem, just move the sphere and find the position at which the corrugation takes on its usual appearance. The second mistake is to create a sphere by clicking and not pulling to the side. You can accidentally create a very small sphere and not notice, and then create another on top. Take a look. The tool tells us there is some mistake here. Let's turn on the topology. As you can see, the geometry passes through each other, and in the place of the hidden sphere, you can see that the polygons are built inside as well. However, at first glance, such a detail can be overlooked. It's important to work out with the movement to the reflex. If you have created a new sphere, don't release the pen or mouse, just move it to the side. To undo the previous creation of spheres, we can do this by returning to the view of spheres, Ctrl Z. By the way, if you want to move the sphere along with the ones created from it, we can do it by holding Alt on the bone, which leads to the sphere from which we will start moving. Look, it should be highlighted in green. Try this action on different bones. Be careful if you can accidentally remove the corrugation, but if you delete it, then nothing critical will happen. Take a look. Create a sphere in the middle of the corrugation and delete it by clicking on Alt. As you can see, our preview doesn't change. To remove the entire ray, we need to remove the sphere that forms it to the very end. So, what if we are fine with the carcass in its preview? Can we start sculpting in the preview window? Technically, ZBrush gives us this opportunity, but an unknown situation can happen. If you start correct something, sculpting, then switch to view with spheres, move the sphere and the preview is rebuilt without what you painted on top. Now nothing will disappear if you don't move anything. Look, our brush stroke have remained in place, but doing this is risky. In addition, this sculpt has limited capabilities. Look, here are the settings of the geometry window. Now click the Make Adaptive Skin button. We have created a new model on top. Let's go into it. Now we see how many settings have been added. With this we can go back to the ZSphere and edit the carcass. And there is a second way not to look among the models for the one in which we can work. Scroll up to the tool window and click Make Polymesh 3D. We can check by clicking on A or Preview. As you can see, we can't even find the adaptive skin window, so we can start sculpting. This way we just keep sculpting and not be afraid that we will lose the whole process if we change the carcass. In the next tutorial, we will start sculpting our dinosaur. Thanks for watching. Bye!